Welcome G. Let's start. So today I am going to talk on thread local variable. So we'll discuss what is thread local variable and what are the use case where we have to use this thread local variable, and also look the code example. So first let's discuss the use case, the scenario and situation where we are going to use this uh, thread local variable, you can say. So let's situation. This is the one applications. One application. Okay, this is one application, and this application let's access by, you can say, user 1, access by user 2, and access by user 3 maybe. Okay, user 3. So generally whenever any request come for serving this user, generally one thread is started. One thread is responsible to serving the user response. Second user, one another threads responsible to serving the request. For user 3, another threads is responsible to serving the threads. Let's example, this is the thread T1, this is the thread T2, this is the thread T3. Now might be case this thread 1 while doing one method invocation, again call another method invocation, again call another method invocation, again call another method invocation, might be call some third party application, and finally return data, return data, return data, and finally this return the respective value. Similarly, this application also invoking multiple method invocation and return the value. Multiple method invocation, return the value. So case number 1 might be I want, our application want to share user information, user detail from this method to this method to this method to this method. Across the method invocation, I want to share my user information, like who user login, which user accessing. So general basic way is right ki you have to pass this user information from A place to B place as a method argument. Again pass from B to C. Again pass from B to C. In this way, generally preference way, we can pass user information as a method argument. This way we can achieve. And similarly for all method invocations. Okay. So another way, instead of modifying the each method call and passing as a user parameter, why not we share some variable like here. Here share some variable like your user information. Store and the same, this method need access, this method need access, this method need access. Any method invocation required user information, they can access it. That's good. But situation, if this is the global variables and access by this user, this is the user 1 information. Now user 2 also required the same thing. If user 2 required going to access, then and similarly might be user 3. So this information user 1, user 2, user 3. If this is the shareable, that possibility thread 1 can access the value of thread 2. Yeah, thread 2 value can access the thread 3. So this is the problem if we are going to access any global resources, because this global resources value of this user 1 can be accessed by T1, can be accessed by T2, can be accessed by 3. So in this case, is there any mechanism where each thread can access own value? Means that thread 1 can only access user 1 information from here. Thread 2 can only access user 2 information from here. Thread 3 can only access from user 3 information from here. So in this case, the answer solution is the thread local. So thread local look like a global shareable variable that can be accessed by any number of threads, any number of user requests. Each thread shape set here his value user information 1 saved by thread T1, okay, and thread T2 saved by your user 2 and T3 saved by user 3. So in this case, if T1 thread try to get user information, they can get only user 1 detail. They cannot access the user 2. Similarly, T2 thread try to access information is this get only user 2 information. And similarly to user 3. That means thread local is the variable that is the shareable across the multiple threads, but each thread can only access his own value. T2 threads cannot access the value of T1 thread. So this is the beauty of your thread local. So let's look the some code examples so that you feel comfortable how we are creating this thread local variable and how thread can going to set value and how thread can go to the get value. Generally, for first user information is calculated and then going to the save here, and later part we can get. So let's write some in simple problem. Let's write one class sample counter, one counter for each user request, request 1, request 2, request 3. So for simplify, I am just using the simply private into request count, request count. This is the only method, number of request count, and you can say this is the one method get, like public and int get only return you the request count. And second, let's each times let's key request 1, request 2, request 3, let's increase the counter. Public let's void and increment increment count, just your right. So now this is the one object which now let's see, you can create the thread one. So the thread 1 equal to new thread, and this is the like thread name and comma you have to pass your runnable object. So here let's say class runnable task, whatever the runnable task, implement runnable. Here simply override your run method. Now here say runnable task, runnable task equal to new runnable task, and here pass your runnable task and your thread name, thread 1, and let's just thread 1 dot start. And here what the logic you have, let's simply they have a, let's assume they are expecting one counter variable. So here you can say private counter variable, okay, equal to new counter. So we have created one variable counter here just for let's key, you can say for let's get 3 requests assume come, let's 3 or 5 requests. simply say our counter dot increment 5 times, and here say s out your counter plus which threads request, counter request by thread dot current thread dot get name. So request counter request count. So simple, let's assume this is the 5 times, simple 5 times just increment counter getting, and we run. So if you run, we are setting ki thread 1 started and they are just 5 requests they are doing, and finally your count should be like okay, should be count dot get, and now you should get the your request thread 1 count. Okay, a request counter by 5 by thread 1. Okay, so let's assume now I started another threads. I started another threads, that's thread 2, and here your 2, and thread 2 also started, and let's run it. So as of now there is no any a simple, this is the thread count. So now notice your the thread 1 request here, name say like a thread 1 request, just I add readability purpose, just commit here and just here plus, okay, thread 1 request counter. Okay, just remove it, just yeah, you can say thread 1 or user 1 request, user 2 request. Okay, so user 1 request, you can say here user 1 request, here user 2 request. So you notice here user 1 requested 5 requests, so still counter from here user 1 from 1 to 5, but user 2 request also counted 10. Why? But the user 2 have only requested the 5 request. So this is the problem, because this shareable variables are accessed by both thread T1 and T2 both. So here how we can solve this problem, because this is user 1 have only the 5 requests and user 2 also have 5 requests, not the 10 requests, because this is the logic for only 5. So instead of using this counter variable directory, why not we set this counter in the thread local variable? So instead of this, so let us write here private static final thread local of counter use the let's key same variable, use same variable equal to thread local with initial value, and just pass initial value like a new counter, and this variable should be static and final so that anyone can access. So now here we have a like a function here counter. Now this counter have a thread local variable, so you can say like set dot get and that increment, and here only say dot get again dot get value. So now instead of using the counter variable, I can say I'm going to create a thread local variable. So this variable is unique for thread 1 and unique for thread 2 and even thread 3. whatever number of your thread you can create. Let's use a 3 request. And you run it. So let's observe what the difference between the normal shareable resource and thread local shareable. So you notice user 1 request, user 2 request, user 3 request, all 5 requests independently. So these counter variables are shared by each threads. That means internally how thread local work, internally you can say one map is created. One map is created. If the key of map should be your thread. So this is your thread T1. Thread T1. What is the value? Your counter object 1. Thread T2 again created thread T2 again counter variable. Similarly thread 33 again created counter variable. So each counter have a start from a 0 to 5. Each counter start have a 0 to 5. Each counter start from the 0 to 5. So now thread local say for each thread this is the share variable, not for all threads share the same local. So previously if you are using without thread local, that means that this is the one counter variable and this is share by all thread. This is share by T1 thread, share by T2 thread and share by T3 thread. So all they are going to increase the value of the same global shareable. So now the difference, these are the global shareable resource. This is also global shareable resource, but for each thread have a own copy of this initial value, whatever the initial value we have a passing here. So in this way you can say for each thread you have a own copy of this global variable. This is the counter. In this way this is the problem. But sometime if you are using this thread local concept as a thread pool, that means the concept of thread pool means ki you have an option in you can specify the thread pool. Let's I define the thread pool of like two threads, and now this is the shareable resources. Thread 1 shareable resource, thread 2 shareable resource. Okay, might be we can multiple task. So in case of thread pool, one thread can be accessed by let's key or task 1, task 2, task 3. We have a 3 tasks, task 1, task 2, task 3. That means ki one thread might be going to run by complete the task T1 and T2. So in this case, thread 1 value stored in the thread local variable can be conflicting. So let's look the example how let's we create like here a thread pool. Executor service dot, let's I create the dot new executors. Okay. Executors just dot I let's create the thread pool of sing. Okay, now created I executor service, and now let's I dot submit my runnable task, and I submitted its same task 1 and 2 and time, and just the dot shutdown executor service dot shutdown. So as of now just I commented this code so that unnecessary. Okay, and let's run it and observe the behavior. Let's run it. So here again, they are still we are using the thread pool. Two tasks here. What happened? I am created executor service of single thread pool. Means this is the one thread. They have only one thread T1, but we have a two tasks. Task 1, task 2. I am saying that task 1 executed by this thread and task 2 also executed by this thread. So the corresponding thread local variable are shared by the thread T1. So due to that, we are again getting the problem same 5 and 10. So how to solve? So in this case, thread local variable is a given one concept key. For each threads, you have to use the concept of your. So solved here. Before going to deep dive this thread local variable have another concept to, you can clean up the store value. So how to do? Before that, let's solve the problem. Instead of using this executor service, we have another option like executors dot. I'm going to new cache thread pool. So instead of fixed thread pool, I am going to use the cache thread pool. And instead of cache, let's give new fixed thread pool. Fixed thread pool. And let's say two tasks, two threads. So that will be here is a 1 1 1. I comment it out and again I run it. So here I am saying we have a pool of two threads. Now two threads, two tasks. Our problem will work fine. There is no problem because here I say in my thread pool there are two threads, T1 thread and T2 threads. Now we have a task also, task 1 and task 2. So this task run by this thread, this task run by this thread, there is no problem. So in the case of thread pool, one thread can be responsible to execute any number of tasks, task 1, task 2, task 3. In this case, our thread local variable is not behave because for each thread, this is the local variable. So that can be serialized by task 1, task 2, task 3. So in this, how to solve the problem this? So let's assume we have a not per task number of threads. If this is the not case, then how to solve the problem? In this case, we have a problem. Might be real scenario is our number of tasks can be limited, but a task can be increased. So for that, in this case, there are methods in the thread local class to remove. So instead of just say try and finally block, you say just finally block, you say yes, this is the finally block and this is the counter thread class have a function like a remove. So once for each threads one activity is done, just remove his own value. And if you run it, that means for each thread local variable there is option to set and option to get. Similarly, we have option to remove. The generally sometime these developers are forget to call this remove method. In this case, there is a serious problem, you can say memory leak. And now you notice we are able to solve this problem. Even any number of tasks you can submit. Now we have only one thread. They are executing three tasks. Still all are working as independent thread local counter variable. All work fine. So this is the one of the important point. Whenever you are going to using the thread local variable, please try to invoke the remove functions so that your application can save unnecessary memory leak problem. If you forget, so if you are not using the thread pool, your application is working fine. But whenever you are going to use thread pool means we have a fixed number of threads. Let's say I've created 5 thread pool. We have created thread pool 1, thread pool 2, 5 pool of threads. Now our application can submit 10 jobs or 100 tasks, 11 tasks. That means कि one thread can be possible to entertain perform the 3 tasks. This can perform the 4 tasks. So this is the beauty of your thread pool. That means limited number of thread can serve the any number of tasks. So in this case, our thread local variable sometimes behave incorrectly. So please be remember you have to responsible to use the counter.remove. So these are the thread local concept and please be remember it. This is the one more concept sometime this is the thread local class have a concept of let's see here scenario again. So now this is the one thread and this now this is the thread local variable. Now this is the thread 1 going set value and they can going to the get value. Similarly this T2 threads, this is the T2 threads going to the set value and going to the get value. This is the set value and this is your get value. Might be these threads going to have some another child thread. So is it possible the what the value this thread set by here they can access the child thread or not? So sometime application required all the our child thread can we get the same value. So in this case there is a concept called the inheritable thread local. So let's look example. Just comment out. So let us I am creating one thread local variable. So let's so instead I am creating the another static final thread local. Let's I'm going to for a string and equal to you can say new okay thread local equal to new thread local. So this is the one way now we can create. So now I can just create a new thread and dot start and here I can say pass name like th1 thread 1 and here I say I can pass lambda expression. So here so now let's I am going to thread local variable dot set th thread 1 thread 1 let's give value 1. I am set thread 1 value 1 and I set okay and let's after that let's do processing. I am just for the sleep let's write one static method void sleep for let's give some duration. So here I can say like thread dot okay thread dot sleep and just the duration of let's key 2 seconds. Try catch exception. So I'm going to just setting something and let's wait for some second. Let's sleep and after that just I'm going to out thread local dot get whatever the value I'm setting. So here you see thread dot name plus what value you are getting. So here what I'm saying ki this is the thread 1 I am started, and this is the thread 1 started, thread value 1 value same, and now I'm getting the value 1. If you run, this is the method to set the local variable, and this is the method to get. So here simple, thread 1 setting the value and getting the value. There is no any. So now you are getting the thread 1 get value 1. It's okay. So now I started one more thread. I am started thread 2, and here I am setting the 2 and value 2. So it is also, instead of just I am also just value 1 value 2. So there is still 2 threads started, 2 are getting the value. Okay. So here question, now this is the global variable. This variable accessed by thread 1 and thread 2. So whenever I am saying thread 1 dot get local, if this thread run, this getting is own value. If this thread run, then they are getting the own value, right? So in this case, if this thread 1 get call, they are getting the value thread 1. Okay. Whenever call thread get this thread call thread 2, they are getting own value. So this is the beauty. Sometime situation, I have created some child thread, you can say. So inside this thread I can create another thread like let's again new thread dot start. So I am just created a child thread, child threads, and just pass lambda expression using runnable access. And here again I want to just print this value. What happened? So this is the thread 2, and thread 2 have another child thread. Now this child thread, let's try to say ki get local value. So this is the child thread and run it. So generally what happen, this thread local variable is whatever the thread setting the values, only those thread can get the value. So here is the problem, this child threads getting the null value. Or even say let's like another simple threads, and let's get thread 3. Let's get, they does not set anything. Okay, just sleep and try to print the value. So you notice thread 4 does not set anything, just want to get thread local variable. If thread 4 does not set anything, they always not get any value, always getting a null value. The thread 4 always getting a null value. Okay. So sometime our requirement, now this child thread can get the value set by its parent thread. So for that, there is another class, is the, you can use the final inheritable thread local string. Okay. So this inheritable thread local class is given options. If this is the parent and this is the children. So here if let's give parent set some value. So here you can say like inheritable set thread dot set, let's say value 2. Let's see, I said the thread local as well as this, and now let's try to print the both value. Okay, this way. So let's assume this is inheritable and this is your thread local. Okay, run it. So you notice that this inheritable thread local, they have options can inherit the value. So notice that this inheritable thread local can get the value 2 which set by here value 2. That means uh, thread T2 thread T2 set this value 2, but child thread can also able to access this value. So sometime if needed situation, so that means for T4 this is the thread T4 and this is the only one global variable, your thread local we created, and the global variable we created the inherited thread local variable. So what happened if T1 thread is started? This is the T1 thread, this is the T2, this is the T3 thread we started. The T1 thread just started set value value 1, and whenever try to get his get value. T2 again go to again, this is the for each thread, this is the for T2. So T2 whatever the value set, whatever the value get T2. So if you know T2 set value 2, they are getting value 2. Similarly thread 4 does not set anything here. If try to get value, you are getting the here null value, because thread 4 not set anything here. But in the case of child threads, you notice child thread means from here another, if you are setting anything here, child inheritance, so child thread of this child thread can able to inherit this value. That means child threads are not setting any value. This child threads is not setting any value. Still they are able to get the value. Here, notice here child threads are only getting the value, not setting the value. Set by the thread. This is the parent thread set value and child thread can get the value. So sometime if you needed key some another threads, so this is your parent thread, this is your child thread. Now they have a inheritable global variable, inheritable thread local variable. So if this parent threads are set some value, generally if this is the thread local variable, if this thread sets some value here, so only this thread can get value. This thread try to get value child thread, they cannot access value. But in the case of your inheritable thread local, your child thread can able to access the value that set by your parent thread. So this is the, if sometime context situation needed, then we can use the inheritable thread local. But generally thread locals are majority used because this is the one global shareable resource for each thread. This is the one one map created, one map internal map created, and key is the, your key should be your thread. Whatever the threads, your key is the thread, and whatever the value they are setting, those value are stored here. This if T1 thread, T2, T3, whatever the thread set value, the same value they can get. If particular thread not set any value, they cannot set any value, cannot get any value. So these are the thread locals. Very interesting thing, but very nice thing. Sometimes they are like method chaining invocation. Threads one invoke to method here, then method here, then method here, then method here, then method invocation happen. I want to share the some object from different places. Just store those object in your thread local. And thread local, your public static, generally it should be public static, so that this class can access, this class can access, this class can access. So without changing your method parameter, method signature, you can share value across the multiple method invocation, and that is thread safe. Means ki for each thread this is the unique copy. Means ki only the thread we set value, only thread can get the value. Rest other thread cannot problem. So one kind of thread safe value look like a local value for each thread, and so that another thread cannot share. So look like you can notice this is the global shareable resource, but for thread specific. Each threads have only access his only own value. Okay, if this thread only can access his own value, other thread cannot access. So you can say thread local is the global shareable resource that is mutated by, changed by any number of threads, but which thread set value, the same value can get by the only threads. So this is the benefit of, you can say, thread local. Sometimes this help us to unnecessary changing the method signature of method calling. So but this again, they have a some kind of advantage, then also some kind of disadvantage, like a memory leak problem. Name also suggests thread local. This is a misleading name, like you can say, but this is the shareable mutable resources, but still the functionality works fine. So you can just as we discuss, these are the things we have to remember. This class thread local class is your java.lang package, and generally whenever we are going to create thread local class, we have a method like while creating thread local we can give the initial value, or with the two flavor like using lambda expressions which I use to initiate the initial value, and after that we have options, give the set value and get value. So this method for setting the value, this method is getting for the value, but for thread specific. And this is the very key method about to remove. Generally please try to use the remove method whenever your code activity is done. And general recommendation, always use thread local variable as a should be static and final. This is the global variable, so that anyone from the whole application anyone can access. So this is the kind of one global shareable resources, any thread, any point, any code base can access, and that is the thread specific value only. And sometime you want the thread one set some value, and I want all the child threads can also access this value. At that time you can use the inheritable thread local class. So these are the one way to pass the, you can say, safe value across the method invocation, and that shareable value are only accessed by our threads. So in short, you can say thread local variable is nothing, just a global map, and the map key is your thread, whatever the threads, your key, and any number of thread in your application can run, and any thread try to get value. I say ki this thread try to get value, so whatever the first check this thread have any entry, then they return. Let's this thread try to get entry, no entry, then you are getting the null value. So each thread have only one specific thread as a key, and whatever the value they are set, those are the value. So the nature of simply this is the one global map, and this map is accessed by any thread. But the only beauty is that if T1 thread try to set or get the only one row entry, specific threads are accessible. This thread T1 thread cannot able to access the value of other thread like a T0 or T5, T0 and T5. T0 thread can only access your T0 value. T5 thread only can access your T5. But this is the T6 thread and this is the T9 threads try to access this thread local variable, there is a no any value exist, so they are getting the null value. And this is your global shareable. So all the method invocation, any layer you can access this global variable, which help us to, you can say, lots of time. Instead of any user information, any credential information, session information you want to pass from method 1 to method 2, method 3, in that place this is the very handy. Without changing the method signature, passing parameter, argument parameter from a method to B method to C method, it thread local variable help us in this case. So might this information is helpful for you, to you. From this note, I would like to say thank you for watching this video.